unmute. So the following functions in ascending order of growth, most of you actually got tricked by me. Mwahaha! Which one is smaller? Most of you got all the other ones, right? Except for F2 and F2. Except for the third and the fifth one over there. Which one is less? N to the 1.1 or n times log of n squared?
N log n squared.
N log n squared is eventually going to be smaller, right? Any log, right? N log n squared is 2 log n, right? Or log n squared, we are comparing log n squared and n to the 1.1, n to the 0.1, right? N to the 0.1 is tiny, but it's still positive and it's going to keep growing, right? And so log n squared is 2 log n, right? And so it will eventually, n to the 0.1 be bigger. We have a theorem in the book that says log n is smaller than any exponent of n, right? But a bunch of you got confused. Mwahaha. A blah is a connected, undirected graph with no cycles? 3. The best sorting algorithm that uses comparisons runs in order of?
N log n.
N log n time, right? The worst case for insertion in the hash table runs in an order of n, right? The adjacency matrix representation of a graph requires order of n squared memory, right? Or v squared. Given t of n less than or equal to 2t of n divided by 2 plus c times n, then t of n is in order of n log n, right? Now, and most of you got those right, mostly. I'm actually relatively happy with the grades. I think the lowest was a 70-something. Maybe there was like a 69, but I think the lowest was a 70-something, which is not bad. I think I forgot what it was to teach grad students. So it's good. You all get good grades. That is good. Or from decent to good, right? And the average is probably 85 or something like that. I think I made it open on D2L. You should be able to see the average and all of that stuff. Given the following graph, calculate the shortest route from A to every node, right? So you needed to tell me from A to C, the shortest route is direct, right? And the cost is 4. From A to E, the shortest route is direct, right? And the cost is 3. And then from A to B, the shortest route is A through E through B, right? And the cost is 4. Right? Given the graph above, provide a minimum spanning tree. And here, many of you messed up because you got confused with what a cycle is, I think. Most of you added E to B and E to C. And then many of you, and those of you who would show me, right, I saw that you thought that adding A to E would make a cycle. It doesn't make a cycle, right? There is no way to go back and forth, right? So what you should have added is A to E. So it's only these 3 edges that form the minimum spanning tree. But about half the class probably chose C to A. I don't know if you're one of those half. And I'm pretty disappointed on that, but that's okay. So that was this one. This one, it got me crying. What are the connected components of a graph? Like, I think only like 2 people got it right, and everybody else told me other stuffish. What are the connected components of a graph?
whatever's connected by edges to your node.
That's one connected component. What are the connected components of a graph? All of those things, right? All of these sets that are connected to each other. Does that make sense? So the answer is going to be a bunch of sets, right? Most of you told me you can use breadth first search and then went to explain breadth first search from one node. That wouldn't give you the connected components of a graph. That would give you one connected component, right? Then you have to say, well, and then pick another node that's not in that set, right? That you haven't looked at, and that when you do breadth first search or depth first search from there will give you another connected component, right? And then if there is still nodes remaining, pick another node and go from there, right? And kind of everybody explained breadth first search. I think I gave you like half the points. There may be one or two people who actually explain breadth first search or depth first search so badly that I took off more than half the points. It's my fault for asking you to write stuff. It makes my grading so much harder. But oh, and by the way, just a quick note: it's breadth, B-R-E-A-D-T-H. Some people put like breath or breathe or other kinds of stuff that kind of. If you do that in an interview, you are probably gonna be laughed out of the room and then eventually not offered the job because you weren't a cultural fit or something like that. Name and briefly describe one of the optimal algorithms for finding an MST, right? You could have chosen any of the three, and I try to see that you actually describe the algorithm. I try to be very lenient, but I took points off many times because you didn't actually describe an algorithm, right? Like you would just say, you would miss at least some of the important steps or pieces of the puzzle. Name and briefly describe one of the divide and conquer algorithms we studied. Surprisingly, almost everybody described merge sort, except for the median. You did the median of two databases? Oh. There was one person who did the median of two databases. Like, just because everybody's going to tell you merge sort, let me tell you that other one, they actually got it right. It's good. Let's figure one more algorithm. That's good. Any particular questions about this stuff, other than individual things about my test? Why did you take 2 points off here? No, life is good. Life is reasonably good. You kind of know the answer.
Do we need to get these back at the end of class, or they are ours to keep?
No, they are yours to keep
Some teachers
forever.
come back.
Yeah, I know. I don't. I'll lose them.
Just based on the class as a whole, is there anything you think that we should look at?
That's a great question. I teach the intro programming class for the people who are about for the transition students, right? So and over there, I usually get 30s sometimes. So I was really happy that there was no bad grades in here, right? I mean, so I think, other than the fact that most of you couldn't remember what a connected component was, right? And so kind of, that was the only thing. Other than that, it seemed reasonable. Probably part of the issues were kind of English issues, where you cannot describe an algorithm to save your life, and you didn't want to go do pseudocode or pseudo Java. So I'm fairly happy. I don't think there is any particular thing.
For future reference, if we just like write out Java on paper, is that okay?
Absolutely, as long as it's right. It's a lot harder to make. It's a lot harder to make Java, but you can write pseudo Java.
Okay.
Yes. Or Don't take it as a challenge, but I can probably understand most programming languages. You can program it. Like, oh yeah, B-Funk, or something like that, right? No, but most of the normal ones, right? You can write pseudo Python rather than pseudo Java if you prefer, or pseudo C++, which looks exactly the same as pseudo Java. But yeah, no, maybe my expectations are too low, but I was really happy. I need to increase my expectations now. Mwahaha.
No, I like where they are. Just throwing that one out there. And also, I think for the question number 9, it probably would have been a lot more clearer if you said all the connected components of the graph.
Yeah.
When I read the question, my thought process went immediately is just you're given a graph and it has a bunch of nodes, and then you have to find all the connected components to that single node.
Wait. There's no connected components of a singular node. There's one connected component that the node belongs to.
In my mind, I already
Yeah,
have a graph there. I'm not thinking of like separate connected components.
Yeah.
So I think if you
Yeah,
the all connected components, it
Yep.
probably would have taken me like another moment. to
Yeah.
do it again.
At least probably hit some more people. Because, yeah, there's only like 2 or 3 people who actually got that one right. Most of you described how to find one connected component from a given node. So yeah, that is a good observation. Maybe I will remember it for the final exam. Sorry? Okay, any other questions or things about the test? No. Given that I saw grading, for purposes of grades, I haven't even started with assignment 3. So for purposes of grading, I'm going to give 100 to everybody for numerical purposes. I will still try to go maybe and give you feedback if you screwed up, but numbers-wise. Oh, assignment 2, I started grading it, so I already messed up with some people, so I will eventually grade it. But 3, I haven't even looked at. Oh, yeah. You horrible you. Okay. Now, let's go talk about one of the coolest ideas ever. Dynamic programming. And it is actually one of those things that's it's an incredibly cool idea. You will see it in a bunch of places. And like it will make you a lot better at programming competitions and interviews and things like that. We have seen, right, 2 paradigms for solving problems, right? One is greedy algorithms, right? Find out a criteria for what's the best thing at any given time and go choose that best thing forever, right? As long as it's feasible. Kruskal's algorithm, you're adding edges as long as you don't make cycles and you keep going, right? Sort them by length, keep adding as long as you don't make cycles until you either have a minimum spanning tree if you want to test that way or you have looked at every edge, right? Greedy is really cool when it works, right? It's usually very, very fast. You're only looking at one thing. What's the problem with it? The when it works part, right? Sometimes it doesn't work, right? Now, we still divide and conquer, which is a very general approach, right? Break up a problem to independent subproblems, solve each subproblem, combine solutions to the subproblems to form a solution to the original problem. That is kind of the most general approach. You could even argue that a bunch of other things are also divide and conquer, right? Now we are going to see one really cool thing when in doing divide and conquer, you have overlapping subproblems. So in order to solve a previous problem, right, or you express it in terms of smaller problems, and you end up solving those things over and over, solving the same problems over and over. Does that make sense? My standard example, and let me pollute your brain because it's not quite divide and conquer, but is, let me pollute your brain first. Fibonacci numbers, right? What happens with Fibonacci numbers?
You set the first one, you set the second one, and then every single one after it is the addition of the last two.
Yep. So what happens, right, with this? How do I solve Fibonacci recursively, right? The standard way. I can do this if n is 0, I'll return 0. And it depends on how you define the things, right? You start with 0, 1 or with 1, 1. Let's see. If n is 0, return 0. That works, that doesn't work.
Else if n equals 1.
Yeah, we can do it like this or this. Else if, yeah, n is 1, return 1. Right? Does this make sense? You get the nth number of a Fibonacci sequence, right? So let's do int public static void main.
If you're an intelligent, you can just say PSVM and hit tab.
Ah, thank you. You are lying to me. Thank you. I like your lies. Cool. I end up doing that all the time. So. It's a macro. PSVM. That's good. Woohoo! It tells me, right? The fifth number is 5. 1, 0, 1, 1, 2, 3, 5. Is the, well, I started counting at 0. So it's the element number 5 of the Fibonacci sequence, right? Let's do this. Cool. Now, do you see a problem with this code? Let me do this. Static, do public static int num12 And here, what I'm gonna do is add 1 to num calls. Right? So let me do this for how do you think the number of calls grows? What does that mean?
Like, I wanted to say exponentially, but, you know, the opposite of logarithm, like,
Okay, that's, yeah. Let's do 15. And let's see what happens, right? I like to use this example because it's super simple and, oh. Or do this. We don't know what happened. What happens with this, right? It's growing, right? Growing relatively fast. What happens with this? It's growing a lot faster, right? What happens if we do 20 instead of 15? Oh, let me do, sorry. I. So now we print I. This is growing way faster, right? Can you see the stuff? So at 19, we are at 13,000, right? So if we were going to do 30, it'll probably take forever.
looks like there are about 3 calls for every number.
Well, for the result, not the number. The number is 29.
Oh yeah, that's what I mean, like, for...
It's about 3 times as many as the
times-
result, right? But what's the problem, right? How is this growing? Looks exponential-ish, right? In fact, let's see.
Is it not n squared?
It is not n squared, right? Definitely not n squared. It is exponential and it's not quite twice, right? If it was exponential on twice, it would be, right? It would be doubling every time. It doesn't quite double. It appears to be 1.6 or something like that. Let's see. Yep. So let's divide 177 by 109. $1.62, and then 287 by 177, right? And I think it is the same thing. Yeah. So basically, it is growing at 1.6, right? 1.6 to the n-ish. Does that make sense? Every time we run it, we multiply times 1.6. So if we were to divide this guy, oops, by this guy, we would get about the same ratio, right? What does this tell me, right? It is horrible, right? It's exponential. It is horrible. It is illegal, immoral, and fattening. Why? What is my problem? Well, what is happening is that I am calling, right? This thing, right? Twice. And I end up, to calculate people of 10, I calculate people of 9 and people of 8, right? But then to calculate people of 9, I calculate people of 8 again, right? And then to calculate people of 8, I calculate people of 7, but I also use it for people of 9, right? And so people of 7 gets calculated a bunch of times, right? Does that idea make sense?
So the further you are, that's the more amount of times you are.
The more times, right, I had to calculate the same thing, right? Does that idea make sense? Does that suck? Yes, it does. How can I fix it? Ish.
Can you start from the bottom up and store every one as you go?
Yes, that is called dynamic programming. How can I fix it without thinking? Or thinking in a different way. What's my problem? Well, I'm recalculating the same thing, right? So what can I do? Those of you who are studying computer architecture, what can I do? Use a cache, right? Store those guys, right? I don't need to think. Public static map integer. So what can I do here? I still increment the number of calls, but now I say if values, or let me call it cache. They call me, I just check, right? And if it's already there, just return it.
And do you have to add every new, how do you add every new one that you make to the cache?
Here. Oh, actually, let me do this. I should have done this. I just replace the name, right? Doing it here, and in here I'm gonna do num calls. So in this, what I do is I get it, if not integer, I can do int, answer equals does this make sense?
Yeah.
This technique is called memoization.
Memorization?
Memoization, without the R.
Okay.
It's making a memo, not making a memory. Don't ask me why, whoever came up with this. McCarthy named it. It's not me. So what's going to happen now? My number of calls is going to be tiny. Well, maybe. It works. What am I calling it? Fibo memo or Fibo? Oops. Oh. What? It was supposed to work like that. Except when it doesn't work. Just do it tiny and then I'm going to add debug statements. Why am I not finding this stuff in the cache?
Could you create the cache outside of the method? Would that help? I don't know.
I did. It is here.
You did, yeah.
Let's do this and let's use our debugger. Maybe. He's thinking about it, right? Yeah. So we hit this guy. N is 2. It's not there, right? So we do run, and what's the next thing? Oh, F over is F8. So I get it called with now answer is 1. I'm going to put it in the cache and return it. So now 1 should be in there, right? And it's 3, that's not it, right? Never found it. Why?
What if you count backwards?
What do you mean?
Like
Oh, never mind. I know what the problem is. This needs to be calling the Fibo memo
yeah.
rather than base Fibo. Stop this guy, toggle line breakpoint. I don't memorize any of those things on my Mac because I spend 8 hours in a Linux box and the keystrokes are different. Yeah. So now I can do this and not die. Notice what happens. What's the extra number of calls for any given thing? Just one more, because I've already kept the other one. Does this make sense? What did I do? What did I transform my algorithm from what into what? What was my growth before?
1.6 to the n.
Exponential. Now it becomes linear-ish, right? Does that make sense? Isn't this amazing? Cool thing about this, I don't really need to think. It's the exact same recursive thing, right? I just store it in cache. In fact, decent programming languages, and maybe even Java, have this as a standard macro, right? You can get a library that will just memoize your functions automatically without thinking, which is incredibly cool. And in this case, it moved us from exponential to linear, right? What is the other way of doing it? Which is what you were saying.
Oh. I don't remember what I was saying.
Start from the bottom and calculate it, right? So get an array and start at 0 and say, you're 0, you're 1, and now I just go linearly, right? In a way, it is what this guy is doing, except that, right, it does it as needed. Does that make sense? So dynamic programming is this idea of if your sub-problems, if the sub-problems that you're trying to solve overlap a lot, if you're solving the same sub-problem over and over again, right, then you can either memoize it, not think too much, just memoize it, and that's it, at the cost of probably worse performance, right? Because you're using maps and right, or figure out how to make a table and fill up the table. Usually, if you fill up the table, you start at the bottom and go up until you find a solution to your problem. Does that idea make sense? Can you see how you would build a table for Fibo? Yes, no, maybe, yes. I'm seeing wheels turning. How could we do this, right? I could do this. I could do array. I could do list. Actually, I can do it like this. I start with add 0 and 1, and then I can go right? And then return values.get and -1 plus values. So now I start and add these two values for my array, right? I could even, shall we do it with an array rather than, there is no particular reason to do this, right? Do a list, except that I'm an idiot. Int values and I do values of 0 equals 0. Maybe with some luck this will work.
And there's still a couple ghost periods.
Ah, thank you. Hopefully we actually get the results that we wanted. If we print them right. Well, yeah, we never get number of calls. It doesn't appear to be working. What's the error in my code? Let's do it here. Okay, I have I is 2, right? So I end up with 1, right?
Should it be I plus plus instead of plus plus I? So it
No, that's the same thing basically. So I'm gonna fill it up. Now values has, yeah, I'm done. Values of n minus 1, so that's 2. Life is good. I printed 2. Now I go on I equals 4. Let's go in there, right?
Should it be I instead of N?
Yes,
this one.
thank you. Thank you. Cool. The number of calls now is useless, but now we should be calculating the right thing. Yeah, yes, of course. Yeah. 1, 2, 3, 5, 8, 13, right? So here at every point, we are using the previous values in our table. Now we build from the bottom, from 0 and 1, right? Does that idea make sense? We may need to check for when they call us with 0 and 1, but does this idea make sense? What is harder to understand?
You mean like between this and divide and conquer?
And yeah, between this and this, basically.
Recursion makes things more difficult in general, I think.
You horrible people, you. Now, recursion is hard when you don't understand it, when you don't use it too much. And so it seems really hard, right? Actually, once you get used to it, it's very easy. But yeah, you probably get out loops a lot more than recursion. I like recursion. But yeah, coming up with this is not always easy. Coming up with what's the table is not always easy. Usually, and in fact all the algorithms will see, you can do it both ways, right? But coming up with that table isn't always easy. Memoization, once you come with the divide and conquer way, memoization is automatic, right? It's something that could be done by a compiler. But it's done by something like a compiler, usually. You don't do it. We do it manually. Does this idea make sense? Yes? Cool. So let's go do it in this, since we have about 5 minutes. With dynamic programming, that is what you do. You break up a problem to a series of overlapping subproblems, right? And build up solutions to larger and larger subproblems. It started in the 50s when a lot of the computer stuff started. And it was kind of World War II, right, or after World War II, all of that stuff. It is applied all over, right? Which is really cool. We used to call this kind of stuff operations research before, in the 50s and 60s. They weren't called algorithms, they were called operations research. So a lot of the stuff that we see now in the algorithms class is, or was called operations research 50 years ago. So, what is the idea? What are we gonna do? What's gonna be our first example? Weighted interval scheduling problem. By now, you should know what's the interval scheduling problem, right? Sort of, kind of, we have seen 17 variations, right? Which variations did we see? You remember one?
The minimizing lateness.
Yes, right? In most of those, we saw 2 of them for greedy, right? And each one of the in one of them we were trying to minimize maximum lateness. In another one, we were trying to minimize the number of jobs that don't get scheduled, right? But those were we weren't caring too much about which jobs, right? Now imagine that to each job we assign a weight, basically money, right? How much are they paying me for this job, right? So now my optimization problem becomes harder, Now it's like, oh, should I add this one? It kills 3 others, but maybe it has more weight than those, right? How can you solve this? How can you guarantee to solve it?
Could you calculate the weight of all that it conflicts with and determine?
But maybe, right, maybe you cannot put, you're getting the right direction, right? But you cannot put all of those that it conflicts with, you may not actually put all of those together because they may conflict with each other. If you don't care about efficiency, what can you do? What are you comparing? Sorry? How long it's going to take? What is your solution? What does your solution look like? What's your answer?
Maximizing weight.
But the answer is not the maximum weight, right? What's the answer? A set of intervals, right? These guys, right? So what can you do?
Brute force.
Brute force it. What does that entail?
Make every possible combination of intervals and find which one
Make
has
every
the highest.
possible subset, right? Does that make sense? Is it dumb? Yes-ish. How many possible subsets do I have?
N squared.
Oh, you wish. You wish. How many possible subsets do I have?
N factorial.
2 to the n, right? Because for every element, I have n elements, right? And I can consider that as either included or not, 1 or 0, right? So that gives me a number with n bits, or 2 to the n. Does that make sense? Does that suck? Yes, right? But I can do it, right? That's exponential, 2 to the n, right? So what can I do to make it better? Consider the jobs in ascending order of finish time, right? As the greedy algorithm did, right? If all weights are 1, then the greedy algorithm works, right? We chose the one that ends earliest, and that's gonna eliminate fewer, right? But in this case, if we had different weights, right, like B was weighted 999, the greedy algorithm would really suck, would get us a terrible weight, right? We can basically do the same, right? Sort them by finishing time, and if there is a tie, it doesn't terribly matter which one goes there, right? And then we need to calculate one more thing, which is P of j, which is the largest index I less than j such that job I is compatible with j. So in this particular case, for job 4, right? Let's ignore that we're starting at 0 and calling 4, right? It's really 3, but which one is P of j? 1, right? That's the largest one that's compatible. Does that make sense? For example, for job 7, what's P of 7? 3, right? Does that make sense? How can I calculate that?
So I guess you have to start with earliest finishing time because you have to make sure it doesn't conflict.
Yeah.
And then does each job have, or you could just subtract the finishing the start time from the finishing time to get its length. Is its weight a separate?
Yes, the weight is separate from the length.
So those, okay, I thought those were.
They're not necessarily the same. They may or may not be. Right? I can sort in order of n log n, right? I could calculate this easily quadratically, right? Just compare with every other guy, right? I can do better. I can actually do kind of a binary search-ish on this sorted array. So what's going to be my, never mind. We end at 15, right? Okay. Next class, we'll continue from this, and we will do a bunch of the other examples. Cool. See you guys on Wednesday, right?
Yeah.
I think I'll stop this one first.